Time to do some homework. We gotta do it! Hey Wildcats, so today we're going to be looking at your 3.1 homework tutorial. So 3.1 is going to be about solving linear quadratic systems of equations. Now, for the most part, you're actually not going to be solving this by hand on a piece of paper like I have here. You are going to be solving them using the program Desmos. But just to show that most of this stuff can be done without Desmos, I'm going to try to do as many of these problems as possible without it. So, let's get started. Problem number 1. How many points of intersection are on the graph? I think they cross. They do. So I was just looking to see if they crossed at all, and this is one of those graphs where it barely catches it, crosses at one point. So how many points of intersection are on the graph of the following system? So if I graph this, I've got a linear graph up here at 8, and it opens up this way, and x squared, so minus 6, this graph's going to start down here, and it's going to open upwards, so 2. Now they want us to solve this graphically. Now, because they're specifically asking me to solve it graphically, let's go ahead and take a look at Desmos for this one. So desmos.com. Alright, and let's go ahead and hop into the graphing calculator. Now, the problem, that's not the problem, was y equals negative, I'm going to write this on my pad here, negative x minus 2 squared plus 4 and negative 5. Okay, so we have y equals negative x minus 2 squared plus 4. And we have negative 5. Y equals negative 5. So this has 2 points of intersection. It's going to intersect right here at negative 1, negative 5. And right here at, you can't see that because I'm in the way, beep, at 5, negative 5. So we have negative 1, negative 5, and 5, negative 5. Alright. So that's exactly what we need to type into our equation here. We have our points, negative 1, comma, negative 5, close, and open 5, comma, negative 5. Check our answer. Negative x minus 2 squared plus 4, negative 1, comma, negative 5, 5, comma, negative 5. Oh, looks like I accidentally hit a decimal point. There we go. Check. Negative 1, comma, negative 5. Five, comma, negative 5. Okay, so this is the one downside of Desmos. Every once in a while you type something in slightly wrong and it doesn't like it. Start over, start fresh. I think I accidentally hit decimal point instead of the negative sign, and then when I erased the decimal point, I didn't see the negative sign. Wasn't there. So Once again, we have another solve this graphically, so I'm going to put y minus 8 equals x minus 1 squared, 2x plus y equals 10. And we're going to go over to Desmos. So this is our old problem. And I'm actually going to move this over here. Yeah, let's do that. So this problem gives us y minus 8 equals x minus 1 squared. And we have 2x plus y equals 10. So I can't see them, but if I zoom out a little bit, I can. And there's a point of intersection, and there's a point of intersection. So now all I have to do is plug those back in to our equation here. So we had -1 comma 12, and we had 1 comma 8. Number 5. Once again, it asks us to solve graphically, so we've got x equals y squared minus 3, negative x plus 2y equals 8. And let's go back to this again. Alright, so it was x equals y squared minus 3, negative x plus 2y equals 8. So we see that this is a quadratic, but it's actually quadratic on the y-axis, which looks kind of funky because we've not seen that yet. However, we can see that it does not cross this line at all, ever. So let's go ahead and go back to the linear quadratic system has no solution. These appear to all be graphically. I had not really looked at these problems before putting this in. So this is what we're graphing. Let's go ahead and go over to Desmos. So here on Desmos, we're going to say y minus 4 squared plus x squared equals negative 8x minus 7. So this is a circle, and x equals y. So we have a circle, and we have a line, and they don't come anywhere near each other. So because they don't come anywhere near each other, when we come over to this, we're going to have no solution. So this says if we need to round our answer to the nearest integer. So that means if it's a decimal, we need to make sure to round it properly. But let's go ahead and go back to Desmos. Alright, so that was 5 minus y equals x squared plus x, and this was y minus 5 equals x. So it looks like I have two spots where they intersect, negative 2 and 3, 0 and 5. We do not have any issues with integers. So let's go ahead and get those plugged in. Negative 2 comma 3, 0 comma 5. Number 8, linear quadratic system algebraically once more. I minus 4 equals x minus 2 squared, x plus 2y equals 4. Okay. Y minus 4 equals x minus 2 squared, and x plus 2y equals 4. They don't cross, so we know that's no solution. And we find no solution here. Number 9. Once again, it's exactly the same basic thing, so we just need to go back to Desmos again. And we get y squared minus 26 equals negative x squared. Another circle, x minus y equals 6. But this is a circle where it crosses, so it crosses here at 1, 5, and here at 5, negative 1. So, back to our program, we have 1, comma, negative 5, close. Other answer is 5, comma, negative 1, close. Check. Done. Again, guys, these systems of equations, it's very important to just realize all you're looking for is where they cross. If they don't cross, there's no solution. If they cross one time, that point is their solution. If they cross more than once, wherever they cross, that is your solution. These first 9 problems, as you've seen, have all been exactly identical. I graph it, I look to see where they cross, and I name those points. Make that the first 10 questions have all been identical. So once more to Desmos. Y equals x squared plus 4. Y minus 4 equals x. 2 points. And our 2 points were 0, 4. One, comma, 5. All right. Our next set of questions are our SAT style questions, but it looks like we've got one more of the same first. So let's head over to Desmos. Y equals x squared plus 2x plus 7. Y minus 7 equals x. 1 point, 2 point. They cross there. Those are our answers. Negative 1, 6 and 0, 7. Okay, for those first 11 problems, guys, I do not expect you to have any issues with those at all. However, here we go. Now we get into our SAT style word problems. Jason is driving his car on a highway at a constant rate of 60 miles per hour when he passes his friend Alan, whose car is parked on the side of the road. Alan has been waiting for Jason to pass so that he can follow him to a nearby campground. To catch up to Jason's passing car, Alan accelerates at a constant rate. The distance d in miles that Alan's car travels as a function of time t in hours since Jason's car has passed is given by this formula. How long does it take Alan's car to catch up with Jason's car? So, we need to set up our equations here. And we know that Jason's car is driving at a constant rate of y equals 60x. So I am actually going to go over to, and that's what I typed in, y equals 60x. Now on the y-axis, I'm actually going to go to, because this is in hours, and our numbers are about to get very, very big, so I'm going to end up having to zoom out here because our distance in the second case, they said it was 1200 x squared. So we have to zoom way in here. So we can see that they start at the same point. They both start here. And as we zoom out, what we really need to do is zoom out on just the x-axis. There's going to be a point way up here where they cross. And it looks like that point might be 0.5. Actually, it's 0.05, comma 3. So it will take blank minutes for Alan's car to catch up with Jason's car. So this was done in miles per hour. And our point is 0.05, comma 3. Okay. So the 3 is the number of miles that they've gone. And the 0.05 is the number of hours. But they're not asking for hours. As you guys can see here, they're actually asking for minutes. And 60 minutes in an hour times 0.05 portions of an hour, well, 60 times 5 is 30, but we have 1, 2 decimal places. That doesn't make sense, does it? 0.3 minutes? Let's do this. No, that was right. It is 0.3 or 0.05. 60 minutes per hour is x minutes per. What is, did I do something wrong? 60 times 0.05. Yes, I did. I forgot a zero spacer. it's not 0.3 minutes, it's 3 minutes. So I was off by a factor of 10 because I forgot my zero spacer in my math. So you can see that if I move this over here, 60 times 0.05, this is 5 times 0, 6 times 5 is 300. Decimal point is 2 places over, so it's 3.0. So 3 minutes. Easy to make mistakes like that if you're not paying enough attention to your scale. It's easiest to not make that kind of mistake if you just plug everything into a calculator while you're doing it, assuming you have one available. Alright, the flight of a cannonball toward a hill is described by the parabola this. The hill slopes upward along the path given by this. So our slope is a line and the cannonball is going up the parabola. Where on the hill does the cannonball land? Round the coordinates to the nearest thousandth if necessary. So all we need to do is plug these two equations in to Desmos. The equations they gave us was y equals 3 plus 0.13x minus 0.006x squared. So there's our parabola. And then the hill is at y equals 0.15x. So double check our problem. Flight of a cannonball toward a hill is described by that parabola. The hill slopes upward along this path. Where on the hill does the cannonball land? Round the coordinates to the nearest thousandth if necessary. So right here. And nearest thousandth is going to be necessary. So we need both coordinates here, 20.57756 and 3.113. So we have 20.756, comma, 3.113. Close parentheses. Number 14. Amy throws a quarter from the top of a building at the same time that a balloon is released from the ground. The equation describing the height y above the ground of the quarter in feet is this, where x is time in seconds. The equation describing the elevation of the balloon in feet is this, where x is the time in seconds. When do they pass? So our parabola is y equals 48 minus 2x squared. And our line, the balloon, is released at y equals 8x plus 6. And we want to know after how many seconds do they pass. It would help if I could type in the right thing. Looks like they pass, since they said time was on the x-axis, they're going to pass in 3 seconds. Oops. So we just plugged in 3. Last problem. Complete the explanation on why a system of linear equation and a quadratic equation cannot have an infinite number of solutions. Only if both equations described have the same curve would the system have an infinite number of solutions. A linear equation will always be a straight line, and a quadratic equation will never be a straight line. So since one of your equations looks like this, which has a curve to it, and the other equation looks like this, they can only cross a maximum of 2 times. That is 3.1 HRW homework assignment, guys. Good luck.